Welcome to our event. This event is brought to you by Datadog's Club, which is a community of people who love data. We have weekly events, and today is one of such events. If you want to find out more about the events we have, there is a link in the description. You can click on that link and see all the events we have in our pipeline. Very important, do not forget to subscribe to our YouTube channel. This way you'll get notified about all future streams like the one we have today. And last but not least, we have an amazing Slack community where you can hang out with other data enthusiasts. During today's webinar, you can ask any question you want. So there is a pinned link in live chat. So go there, ask your questions, and we will answer these questions after the presentation, right? Or during, how do you prefer?
I think after the presentation, unless you want to interrupt and say something urgently.
Okay, so after the presentation, then, yeah, please use this link for asking questions, and we will make sure to cover all these questions, or most of them, depending on how many of them will be. Anyways, I think I need to stop sharing my screen. And now, Elena, the floor is yours. It's always a pleasure to have you. Finally, it's been a while since your last appearance here. So yeah, we needed to fix that. And finally, you're here again. So welcome.
Yeah, thank you for having me. It was since pre-LLM era. So now it's going to be a talk about not just ML, but LLMs. So let me share my screen. Please confirm that you can see it.
Yes.
Perfect. So today I'm going to talk about a gentle introduction to LLM evaluations. And this is the topic that is quite dear to me, having been doing machine learning for quite some time, and now thinking about how we can apply some of the learnings from classic machine learning to LLM. So I've been doing machine learning for more than 10 years in non-technical capacities, mostly. So I was on the product side, on the business development side of it, but I've seen quite a lot of things. So since before it was called big data, AI, machine learning, and now LLM. So I'm drawing on this experience, and I'm a CEO and co-founder of a company called Evidently AI, where we build open source tools to help you evaluate, test, and monitor machine learning systems, including LLMs. So let me just quickly hide the video, and yep, that should be all right. So when we talk about LLM evaluations, we usually mean one of the two things. And if you Google this, you will stumble upon either of them. So one is talking about evaluating LLMs themselves. So meaning when we're evaluating different models and comparing which one is better and how they perform on a broad range of tasks. So every time you see a new LLM released, it comes accompanied with like, hey, this is better than something by this dimension. So this is what we talk about when we talk about LLM evaluations. There are different methods. I'm not going to talk about it today, but just to avoid confusion, this is not what we're going to talk about. What we're going to talk about is more about evaluating LLM-powered products, which means systems that are built with LLMs that you are specifically applying for a purpose that you chose. It could be a chatbot, it could be some email writing assistant, it could be a completely new product powered by LLM. And essentially, when we talk about evaluating the LLM-powered systems, we care how good the complete system is. It's the model, it's the prompt, maybe it's some other components like some business logic, vector databases, and so on. And that is what we're going to talk about today. So one more way to focus on what we're going to discuss is to define the idea of an LLM-powered product. So in this case, it can actually be either a very new product that is completely powered by LLM, or a feature that is inside an already existing product. I think we've all seen things like coding assistants, maybe like AI copywriters, completely new workflows that are now powered by LLMs, usually in the form of agents. So this is one side of the spectrum. And another one, you might have some features on the back end of some process. Maybe you drop a PDF file and it automatically extracts some information to prefill some application form. Or maybe you write an Amazon review and it automatically suggests you a tag. So these type of applications are now also often powered by LLMs, not necessarily classic machine learning systems. But the degree to which you care about the evaluations and the quality will obviously vary. So if you're building a new product that is completely powered by LLMs, you're probably going to care about this a lot. And evaluation workflows are going to be a huge part of your development. Whereas if it's just a backend feature, you're probably going to test it a little bit and then just live with it. This is the reality, not caring too much about evaluations in practice. And of course, it's always a spectrum. So I'm going to err on the side where LLMs are really important and thus evaluations are really important. And when we talk about evaluations, there are several modalities when we need them. It is both before production and after production. Before production, we usually discuss the idea of experiments. In traditional machine learning, we talked about experiment management. Basically, when you try different prompts, models, combinations of parameters, and you want to understand which one is better, to choose which one to proceed in your development. Another more peculiar way of evaluation is when you stress test or evaluate your LLMs in particular scenarios. So this is usually when you already settled on some initial design, and now you want to maybe see how it performs within a particular scenarios to make sure it's good enough to go. And then if we go to production, you obviously need monitoring. You need to understand how the system works in real world environment, and chances are not how it was behaving in testing. And I would distinguish between monitoring and analytics a little bit, because monitoring is more about quality, whereas analytics is a bit more about understanding how users interact with your system. Like, for example, what are the most popular topics that are being asked from a chatbot, or like what languages the users use, these type of things. And last but not least, there's a thing called guardrails. This is near real-time detection of bad inputs or outputs, meaning that you're not just monitoring something after it happened, but you actually want to intervene directly when you generate the response. So for example, if the response is bad, you just regenerate the response or say, no, sorry, I cannot answer. All these things are in the end evaluations, because to assess or to detect something, you need to run an evaluation on the input or output. And also there is one more modality which I call regression testing. I think it's very familiar for software engineering. And it comes both pre and after production, basically when you want to evaluate if after you change something in the system, it does not break some behaviors that were good before. So for example, after you change a prompt, you want to understand that the previous generations are still good. And you could do this in production because often you have to fix some things. And in this case, after you fix them, you obviously need to reevaluate how it affects not just the bug that you are addressing, but generally the behavior of the system. So as you can see, evaluations is a lot of things, and you need quite a lot of them to work in different scenarios. And I've said evaluations probably already many times, but every time we say evaluations, you can imagine different things, right? So what are specific quality dimensions that you may be paying attention to? There are, of course, things which are purely technical. So for example, how fast the model response is, or how frequently it returns errors. I'm not talking about this part because it's more like traditional software quality dimensions. But here we talk more about the quality of the LLM output. And depending on the use case, it can be something like, is the LLM response safe? And especially if provoked, because probably in modern LLMs, they don't curse at you unless you actually try to somehow provoke this behavior. Or maybe it can be the most simple things like how frequently does it return incorrectly formatted outputs? Because you might ask to return specifically JSON of a certain structure. You might ask to include a link, and then you just need to see how frequently this happens or it does not. And of course, this type of relations, they're very use case specific. So unlike, I would say, traditional machine learning, there are where we usually talk about things like accuracy, precision, recall, so more well-defined measures of quality. With LLMs, we usually talk about something that is very custom and specific to the use case. And a lot of things can go wrong. So I personally collect quite a lot of these examples. I think we should maybe assemble a block at some point where we see how LLMs can exhibit behavior when especially provoked by the users that lead to something like agreeing to sell a car for $1, or maybe cursing on the user, or maybe talking about competitors, like having a poem written about why your product is bad. This is obviously not what you expect from a product that you expose to the users, but these things can happen. And because we are dealing with open-ended outputs, it can happen even more frequently than with predictive systems. So this is something that you have to think about, and this is why evaluations matter. So it's both quality of the product, and it's some risks that you want to protect against. So let's finally get to the topic. So how do you evaluate the LLM products? One point I want to make is that still these things are not entirely new, right? So we have machine learning products in production for over a decade, I think. They're starting from search engines to recommender systems to fraud detection systems and so on. And they exhibit the same traits as LLMs. So they're complex and non-deterministic, and we have some how to deal with them in production when they're deployed in some high-risk scenarios. And just to differentiate this, so when we talk about predictive systems, this is usually when the output of a system is, well, a prediction. So you say, for example, a certain transaction is a fraud or not. Or maybe you predict the volume of sales of a specific product in a specific region. Or maybe you just predict if a certain document is relevant to a query or not. So in all these scenarios, you return a prediction, which is a well-defined output out of the possible values that it can return. So either a label or a number or a score and so on. When we talk about generative systems, they return open-ended outputs. So they can actually generate text, or they can generate code, or anything else which can not specifically fall into like a very defined format. And that's why it's great, because now we have so many new capabilities powered by LLMs, but also that's why it's more risky and harder to evaluate. I would say it's important to say that generative systems are also not new, right? So we had translation or summarization done with more classic natural language processing techniques, but now most of these things are done with LLMs. So how do we evaluate the predictive systems? That's something that we already used to seeing for these decades. And I want to make this distinction. I mean, it's sort of obvious if you worked with LLMs, but I found that when you talk to people who are completely new to the like Gen AI applications, it's a bit non-obvious. So most of the evaluations of the machine learning systems actually happens offline, meaning that you work with some static data set that usually comes when you train the model together with the training data, and then you try to predict something on the part of this data set and evaluate it against the true labels. So there's like a whole process how you do it, right? So how do you make the split? How do you make sure that you don't just memorize the answers? So it should be done like in a careful way. But the obvious thing is that you actually work with offline evaluation. So we don't talk about here about detecting somehow the quality in near real time. We talk here about evaluating the quality against known ground truth. And actually it's complicated even this way. So you would assume that maybe if you know the answers, it's very easy to say that if you're right or wrong. But actually, even when you know the answers, there are so many metrics that you can use, right? So precision, recall, accuracy, this is just a very obvious example in classification, because each of them conveys a slightly different meaning. And when you optimize for a particular metric, you need to know what you're optimizing against. Maybe like a better example, because it's still very relevant for LLMs, is from ranking systems. So there are metrics like NDCG, which is rank aware, or precision, which is not rank aware. It means that when you're predicting something and sorting the recommendations, for example, in order, the first metric cares if the better recommendation is above non-relevant ones, and the second metric does not. And sometimes it doesn't matter for you either. So you can choose one metric or another to optimize against. So this is what happens when you do offline evaluation. And what happens in production? So this is, again, a topic very dear to me, because pretty much we've been focused on machine learning model monitoring for the last 3 years. And again, just to state the obvious, when we talk about monitoring machine learning systems, we actually monitor proxy metrics, because normally we don't have the chance to evaluate the true quality until later. So we look at things like data quality. Is the model getting the reliable inputs that it should be able to process well? We look at things like data and prediction drift, basically to understand if the model still operates in a familiar environment. And if we can, which we cannot always, but sometimes, we look at proxy metrics like are the users actually clicking on the recommendation block? And if they're clicking less, maybe there is something wrong with recommendations and so on. And then after some time, we usually get the labels. So for example, if you're predicting demand, after some time, you actually know if the predictions were right or wrong, because you know the actual sales. Or in other scenarios, like fraud detection, you might get like some disputes resolution and actually know that certain prediction was fraud or not, and so on. But not often, not always, and sometimes you have to wait quite long. And because of this, you might even build like a separate process where you actually label some data manually by hiring experts to do this, so that you can compute the true quality metrics. So you review some portion of predictions. And the key learning here is that we heavily rely on the pre-deployment testing and evaluations, right, before you actually deploy the system. And we assume that if we tested it well, the scenarios where the model is applied are representative, do the training, so we can actually hope that it works as good as it was in training. So what can we learn from all this predictive ML when we apply it now to LLMs? So one thing is that, well, LLMs don't give you a free pass on not doing evaluations. Just because you have the model somewhere done, you still need to evaluate it on your specific task. And you need it at all stages of the life cycle, like we discussed. And I think it is sort of like what is very deceiving now about LLMs is that it's so easy to create a prototype and start doing something that you sort of assume that somehow the quality should also figure itself out. And it's true that in some scenarios, especially like low risk ones or something that you do for yourself, where you manually review each output, you probably shouldn't care about like very comprehensive evaluations. But if you expose something to the users and they will probe and test and use it in ways you didn't expect, well, evaluations matter a lot, so you still have to work on this. And one more thing that we can learn, which I think is like the one point that is non-intuitive at first, is that you still need to create this evaluation data set. With traditional machine learning, we take it for granted because our evaluation data set basically comes together with our training data. And if there is no training data, then we don't have the model, so we don't do any machine learning at all. But with LLMs, we start with ready-made model, so we don't have this data, right? And you somehow have to curate it on yourself to start evaluating it on some set of scenarios where you expect it to be used. And this is huge work, so this is not easy. And unfortunately, if you skip it, which you can, if you can do like some sort of beta testing and then start collecting this data from real users, you still need to continuously work on it. And when I talk about evaluation data, I mean, first of all, some input scenarios, like type of questions that you expect your users to ask, for example, that you want LLMs to handle well. And ideally, it should also include the expected answers that you manually pre-approved or labels as relevant or irrelevant and so on, to basically show what should be done in ideal scenario. And you can think about this as a very like comprehensive exercise. So it can be some very popular cases that you should handle well. It can be some edge cases that you should either handle well or say that you cannot handle them. It could be some adversarial inputs, like you can ask your chatbot about competitors and you should expect it to not answer or say something like canned response. And again, this is hard work, and this is probably the moment when it becomes complicated. You can use some synthetic data, and this is actually a very good start, but you should always continue expanding it, picking real examples from real users. One failure mode that I have seen right now is, for example, when people work on RAG and they have like some sort of knowledge database, and they generate synthetic questions that can be answered from this knowledge database because they directly pull them from the knowledge database. But realistically, they should actually look at the previous questions the users asked, for example, interacting with their support agents, because sometimes they don't have answers in the database, right? So you should actually see how you handle things that represent user behavior, not the material that you have at hand. And I know that it might, again, sound like it's too much work. Obviously, there should be some automated way of solving this. But let's look, for example, at how Google does it. It's a search engine. So basically, it solves a thing, information retrieval, that is now part of RAG, that is everyone doing. And in order to evaluate the quality of search, Google actually has a lot of experiments that they run, which rely, among other things, on manually labeled data, meaning that they hire assessors, or like I think they call it search rankers, who follow a 150-page guideline to label particular resources as relevant or not. And then having this as ground truth, they can actually evaluate certain experiments, like does it improve something, does it improve the quality of ranking, and so on. And even Google does it, right? So for your smaller applications, you cannot go away without. Maybe get a bit closer to reality. I was going through some blog posts of how different companies applying LLMs, and there was one example from Segment. They implemented a tool which basically allows you to create, let's say, like text to SQL. In their case, it's not SQL, they have their internal language, but something that allows you to generate a query to define an audience that you want to work with. An audience as in like query your customer database. And to start working on this project, they first pulled real audiences that users previously created. Then they generated potential questions that they might be asked to generate this audience. and then they tested against this baseline. So basically, they started with curating a test data set with known good responses to possible questions. And this allows you to iterate on the quality of your system. And one more thing to summarize from like this vast world from predictive machine learning to generative is that sometimes actually with LLMs, you still solve predictive tasks. By predictive, I mean often it's classification. For example, the first question that a user asks to a chatbot, the chatbot classifies this into a set of topics and then chooses a possible prompt. This is actually a pure classification task, right? And you can evaluate it as a classification task with a separate data set, like different types of questions, then correct intent detection, and then you just like evaluate precision, recall, and so on. And it might not always be obvious, especially like if you look at like agent, it's so complicated. And of course, there are ways how you can evaluate the complete flow, but you can also break it into smaller testable components and then like rerun it on whenever you need to run the evaluation. And it will be very constrained and very easy to evaluate. And one thing to mention is bringing in domain experts. I think that was always like the crux of all successful machine learning deployments, that you need to know basically what you're getting into, what's the actual product, what's the actual use case, and bringing domain experts to help you define what you're doing. I think now it actually became even more important because now we're working with texts, you can read them, and usually these are domain experts who can help define both quality metrics and also like curate these test scenarios, write these possible questions and so on for you to evaluate against. So in this case, I think like now it's even more important. So collaborative part is something that you should start with. And then of course, there are some things that are completely new for LLMs compared to predictive machine learning. Some are better, some are worse. So I would say on the more complex parts, because we have now this free-form texts, there are more issues potential, right? So before you could just be incorrect, now you can be incorrect, but also biased. Your chatbot can promise something that you cannot do and so on. So you have to evaluate like against more potential negative scenarios. Another thing that is more complex is that we're now evaluating not just the input-output pairs, but actually complex interaction chains. Like you have a set of questions, answers. So it's a complete dialogue, which might also involve tool calls. So of course, this is much more complicated than just input features, prediction that we used with classic machine learning. And one more thing is that because we have these open-ended outputs, there is actually more than one way of being correct. So before you had like only one correct label for a given input. Now you can actually have like, I don't know, hundreds of different ways of explaining how you can achieve a certain thing that will be completely coherent with your knowledge database that you're extracting the information from. So you basically need different metrics for non-precise matching to evaluate correctness. But also there are some things that are much easier, and I find this actually quite refreshing. First of all, that you can actually read everything, right? You can read and comprehend and understand it yourself. And this is very useful. So you can review any answer and yourself decide if it's good or not. And more than that, you can actually, without assessing the final quality of the answer, you can easily assess some of its properties, like is it polite, is it verbose, even automatically. So this allows you to monitor something in production without having ground truth labels. And finally, because we have these powerful LLMs, you can actually use these LLMs to evaluate your LLMs. So this is something I'm going to talk about in a little bit. So finally, how to evaluate the actual LLMs? Having said all this, having learned all this from predictive systems and having faced all these new challenges that we have. Broadly, there are three methods to think about. One is ideally, of course, we can do complete quality assessments and do this human labeling. There is a way how in the industry people call it now vibe checks. By vibe checks, I mean we just like sporadically look at individual outputs and decide if they're good or not. I'm not talking about this. I'm talking at like a more systematic process when you actually manually label every output and you see if it's good or not. You can do it yourself. You can outsource it to someone, but you can actually like manually review the answers. Of course, not in production, but maybe before production. And then on the tip of the iceberg, you can actually look at the product metrics, such as are the users actually engaging with the LLM-powered feature that you implemented, or like how frequently they accept the generations, or maybe how frequently they correct them. what is the total time spent interacting with a chatbot or feature. So when it's just a feature, maybe it's more or less enough. But in most scenarios where you actually care about quality, you want to find like some middle ground where you would run automated quality evaluations that would work at scale. And I've listed a few methods here. I'm going to talk about them, and in particular about the LLM-as-a-judge approach. So, but to say about human labeling, it's not as impossible. So here is an example from Asana, from one of their blogs. They explain how they're testing different LLMs to power their features. So Asana is a product management software, and they have like some sort of question answering system that they implemented within their product powered by LLMs. And they curated some real world questions and answers. And then a product manager was actually labeling these responses under certain criteria. And it might not be how they're going to do it forever, but in the beginning, it's actually great. You should do this because these type of things, they also create some ground truth for you to later try other evaluation methods, including the LLM-as-a-judge approach. I'm going to gloss over this. So we already talked about the predictive metrics. So there are a bunch of metrics which allow you to quantify the results when you compare against the known good response. So for predictive metrics, it's obvious. For generative applications, you can actually have like some things that quantify overlap between text. So for example, your generated summary against LLM generated summary, and then you just like count the overlap in terms of words and expressions. This is not extremely useful unless you have these good summaries, but sometimes you can still apply it, especially if you have like a previous reference response. So something to brush up if you haven't seen before, read about this type of metrics. And then there are things like we're jumping from very complicated to very simple, like text statistics. But what we've noticed working with users now who evaluate LLMs, things like text length, it almost always comes up, right? So you just want to see like how long the responses are, or if they're getting longer, or if you have like the different lengths of response to the same question. So these things are very easy to compute, and you should absolutely do it. And it's fast, it's cheap. Of course, it doesn't say everything about your quality, but this is a good metric to compare. It's very easy and very cheap. And then if you work with a particular use case, like this example from segments, or maybe something like coding assistance, you can actually test if the generated response is valid, right? So you can execute a code in some sandbox environment, of course, and see if it's valid or not. Or like if the SQL is actually like a valid SQL, or if the provided link actually returns something, or it's just a completely hallucinated link. So it does not work for all use cases, but when it is possible, you can just do like this type of functional programmatic testing, which is absolutely great. Just think if you're working on this type of use case, how you can run this type of validations. And then another thing that's kind of goes along like this type of functional testing, it's very deterministic, is using regular expressions. I know it sounds very old school and not cool, but realistically, you can achieve quite a lot with regular expressions. By regular expressions, I mean, for example, checking word lists or like specific strings that are repeated in the responses. And it is useful in many scenarios. So one is like mentioning competitors or brands or particular products from a product line. Another one is topic analysis. So yes, of course, you cannot define all topics just by words, but you can define many topics like this. And I don't know, if you have a family planning assistant, just the word school will cover a lot of things like that you want to detect. Like, is it conversation about school, or is it conversation about health? Or for example, we were like applying checks for detecting denials. By denials, I mean when LLM says basically, sorry, I cannot respond to this question. Yes, you can use like more sophisticated methods, but very often when LLM says no, it basically says sorry, or I cannot, or apologies, or apologize. It's a very limited list of words. And there's a benefit to using this type of checks because it's fast, it's efficient, and it's deterministic. So you exactly know what you check for, right? If it's true or false for this specific pattern match. So it will not be maybe perfect precision, neither perfect recall, but it can be very competitive compared to other ways of evaluating this. And I think this should be number 6, but let's go with this. Then we can also use machine learning models. So now we're getting into like some more interesting type of use cases. When we use the power of machine learning to evaluate the LLM outputs. In this case, I'm talking about not using LLMs, but rather talking pre-trained machine learning models where you do not like generate additional prompt. You just go with the model how it is. And one scenario is using embeddings model to detect semantic similarity. This is particularly useful in cases like regression testing, when you want to compare the previous response against the new generated response. And like in this example on a screenshot, you can see that, for example, if the response is identical, the embedding model can easily match it. So even if it's not word by word, the similarity is very close. In this case, it's like a sign similarity computed over the obviously embedded texts. Or you can see that in this case, like instead of sending to an agent, actually LLM generated a response. And in this case, the similarity was obviously low. So it helps you detect these differences like very efficiently. It's not perfect because in this case, like for example, if texts are different lengths or if texts are generally on the same topic, but then there's like one small contradiction, it will not catch it as precisely. But for like more crude evaluations, it's actually quite useful. I think in the Zoom camp and in the LLM Zoom camp, you used semantic similarity for the text evaluating the quality of questions, right? In RAG.
Yes.
Yeah.
Exactly.
So this is the type of use case where you can use it. It's not perfect, right? But it's a very good proxy. So if it's completely unrelated, it would say like, yeah, it's lower than it was before. What's worth mentioning is that semantic similarity heavily relies on the model that you use for embeddings, right? Some of them like better for short text, some for longer text. Obviously, there are like language models and so on. So it's something to consider. But again, it's a great method. Obviously, like you can try and test how it works, and then if you need to upgrade into something else. Again, just to validate what I'm saying, I think it was like GitLab. I was going through their documentation because they open source quite a lot of things, and they're sharing like how they evaluate their coding assistants. And you can see that they're basically using similarity scores, and they're also using something called cross similarity, where they compare similarity between individual sentences that are extracted. In their case, they're comparing code, so it kind of makes sense because they're comparing not just the meaning of it, but more like is it semantically similar what is expressed in this particular line of code? So again, something to consider. And then when we talk about machine learning models, it's not just semantic similarity, actually it can be any machine learning model, including machine learning model that you trained yourself, specifically for the purposes of evaluation, which I believe is going to be more or less the end game. But this is not what we're going to start with. Personally, like I experimented quite a lot with Hugging Face models, when you just basically can find some publicly available open source models on Hugging Face and see if you can apply to score your generated responses by, of course, whatever this model does. So in this case, you're working with the existing model, so you can only rely on the outputs that it generates. But it's very useful in certain scenarios like PII detection. I mean, there are many great tools that helps you detect personally identifiable information. You don't need to always use LLM for that. Though you can, especially if you have like your own definition of what's personal, but you can also just go with something pre-trained. Topic detection, sentiment analysis, emotion detection. I think there's a great model on Hugging Face that classifies text by 27 emotions. So on this screenshot, I used it for neutrality detection, or more like detecting texts that are not neutral to actually look at them. And this is not as fast as regular expressions, but it's much faster than working with LLMs. And if you have large data sets, you can actually maybe do like a first pass where you evaluate something with a machine learning model, and then second pass where you evaluate some other things that were not caught by this machine learning model with LLMs. And as I mentioned, I think in the end, when you know specifically what you want to detect, like within your use case, within your LLM application, you can actually have like a pre-trained model like BERT, and then actually fine-tune it on your own data. And we're not talking about fine-tuning LLMs, we're talking about fine-tuning just classic language models, which are fast and local to run. And now we're getting to the most interesting part, I think, which is LLM-as-a-judge. LLM-as-a-judge is the approach where you send the outputs of your system to the LLM. So basically, LLM is evaluating LLMs. I know that some people react to this idea like, well, why don't you do it like better in the first place? If the LLM is not as good in generating a response, why should we be better in evaluating the response? But truth is, classification is actually much easier than generation, right? So when you generate something, especially within like a complex flow, where the LLM has to keep the context of the previous conversation and it acts under a specific prompt to response, to respond, it's very different from evaluating the response. Basically, like saying, is it good or bad? Is it polite or impolite, and so on. And the benefit of this approach is that it's perfectly customizable. In this case, we're not talking about metrics per se, but rather about a replacement for human labeling. So we're using LLM for the same purpose as we could have used a human labeler to classify or categorize the response under specific criteria. And this criteria can be something custom. There are different ways how you apply LLM as a judge, and I think it creates confusion because, like, if you Google or read some reports, people say, no, LLM judge doesn't work, LLM judge worked great, so it's kind of confusing, but it's actually used for different purposes. So one is pairwise evaluations, like when you show the LLM like two responses and ask which one is better. I'm not actually talking about this. So this type of choice is more relevant when you may be training the model or when you're comparing two models in the beginning. But if we talk about monitoring, you don't have two responses to compare. You usually want to evaluate the one response that you got. You can also do this kind of like semantic similarity checks, but with LLMs, when you basically ask LLM to compare against the ideal response and say how different it is. And lastly, you can evaluate the LLM, you can evaluate just the response, right? So no comparison, just assess this response based on whatever quality you defined. And in this case, you can, of course, you can just pass the response, but you can also pass the response and the question and ask something like, hey, is it relevant? Or response and the context, and then ask something, hey, is response grounded in the context? Or maybe, like as I mentioned, answer and reference and so on. So it can be passing multiple pieces of text to evaluate them together. This is something that pretty easily done. It's just the same prompting that you can do with when you create the LLM product itself, right? It's just a different evaluation prompt that you run. And in this case, it's always best to use the more powerful LLM because, well, it has usually better abilities in detecting things like this. I know that I think LLM as a judge is now like a pretty debated topic. And I would say the differences are in how you use it, right? So you can ask very complicated things, you can ask very simple things, you can have like very elaborate metrics that you try to compute and so on. So my opinion here is based on the experience that we had now working with different applications. And the advice I usually give is just to keep things simple. So use binary classification. So don't ask like for grading between 0 and 100 or like a very complicated flow. Just ask like, is it good or not, relevant or not? There may be like 3 classes, like relevant, irrelevant, partially relevant, but not more than that. It's also useful to get unknown, unsure class. So in this case, like if there is not enough information in the response, say unsure. Don't try to guess like if it's relevant or not. Because like if the response just says like apple, you don't know what to say about it. And if you try to come up with some more complicated criteria, it makes sense to actually split it into several judges because LLMs, they're not so good at reasoning, right? So it's not a reasoning engine. In this case, it's more like predicting the label that is following from the text. In this case, like you can separate things like, hey, is the answer complete? And then like, is the answer contradictory? Or is the answer relevant? When you say like, hey, please assess this answer if it's contradictory but relevant, if not contradictory and no relevance, it's something like very complicated, even a human cannot follow this always. So try to make it like very simple. One thing that I cannot stress enough is that you should always read the prompt. So if you're using the external evaluation library, understand how it evaluates things because these are not metrics, these are prompts. So you should know what are the criteria that is being judged against. And ideally, you can also write this prompt, not just read it, and so on. And if you're writing the prompt, or if you're actually applying someone else's prompt, I always recommend to start with like your own label data set. In this case, what I mean is, for example, here I tried to write a prompt for correctness, comparing the ideal response to the previous response. And before I tried writing this prompt, I actually created my own data set based on previous examples where I manually labeled new response as either correct or not. And then I commented something like why I considered it correct or incorrect. And actually, the process itself is very revealing because when you look at how you yourself grade something, you understand what you should direct the attention of LLM as well. Because in some cases, like for example, the small things like adding check your spam folder doesn't matter. But in my case, I thought it actually matters. So I wanted LLM to detect the small changes as well. And this, of course, propagated into how I wrote the prompt after I labeled it. And then after you write the prompt, and you generate the LLM responses, in this case, asked both for the category and the reasoning, you can actually compare your own responses against the LLM responses and quantify it. In this case, I just treated it as a classification task because I actually was mostly interested in how good it is in detecting the incorrect responses, because this is my target class that I wanted to manually review, like if the new responses are different from the old ones. So I would probably skip on this a couple of special cases if we want to discuss it as a Q&A about RAG and agents. And let me jump directly to what I think you can do right now. If you're like working on some LLM use case for the first time, and I know that was a lot, but we know that in real life, we don't always have the time or the ability to build all the processes from the ground up in a perfect way. So where do I think you should start if you have like initial project that you're working on and you want to build evaluations? So first of all, start logging your inputs and outputs. If you don't do this, nothing makes sense in the evaluations because you don't have the real data to look at. And if you have like some test users, or maybe you're like interacting yourself with your tool, just start logging the inputs, outputs, and prompts, because then on top of this, you can run evaluations, you can build processes. But if you don't trace them, there is no way how you can continue improving or understanding what's going on in your application. So this is ground zero. Then I would suggest that you build a very simple evaluation pipeline. Just like not to stretch yourself, curate 10 cases. I promise you can curate 10 cases in like 10 minutes. You can, of course, like try to go beyond that, but the point here is just to build a very simple pipeline. And then after you have like these test cases, but test cases, I mean like the expected inputs, some like questions that you expect your LLM to handle, you can build a very simple evaluation pipeline where you get these inputs, you call your product API. In this case, I stress that you're not just calling the LLM, but if you have the product API exposed, like for testing at the test stage, then you should call it because it has probably something else, not just the prompt. Then you generate the responses, and then you evaluate something in these responses, like text length, maybe detect that it's not 0, and then you record the result. The importance of this is that you have like a very simple pipeline that you can later improve, right? So you can add more test cases, you can add more evaluations, but if you don't create this as part of your workflow, it's much harder to add it later compared to starting with this as a solid process from the beginning. And if you're thinking about like what to evaluate, I think regression testing is the lowest hanging fruit. So in this case, we talk about detecting if the responses to the same set of questions has changed. Ideally, you can curate this like responses as we discussed, the golden data set. But if you don't have them, you can actually have the responses that were generated previously, right? So you had like maybe some test data, you were interacting yourself with your tool. And if you recorded the results of these interactions, every time you change a prompt or modify something in the system, you can just generate new responses to the same interactions and then detect the difference. And in this case, you can either use the semantic similarity or LLM-as-a-judge, which is tasked with detecting this difference, just like I showed in the example. What this gives you is the ability to look at the responses and basically understand what changed. Like now that we changed from GPT-4o to GPT-4 mini, like are the responses different and where are they different? So understanding this can help you basically see if you're improving or regressing or what is changing in general in the behavior of the LLM. And lastly, bringing domain experts. So in this case, when we talk about like what the LLM should say or should not say, this is rarely just the engineer who is responsible for this. This is something that domain experts usually know much better, like what type of questions to ask. And if you ask the domain expert to review the responses, they will probably start like with manual logs, and you can label like what you like and what you don't like. And after you do it for a bit, you can actually describe what you decided, right? So why it was good, why it was bad. And then you can try to automate yourself, like as an evaluator, by creating these LLM judges or just word lists using regular expressions to detect what you want to detect, right? Maybe particular examples like when the LLM denies a response. So these type of things are pretty easy to implement at start, but it requires someone to start with looking at the logs. So these are my takeaways for today. Like if we try to summarize it, it's first break down your LLM-powered products into smaller components. Like I said, like if you have a complex chatbot, maybe you can have like intent detection as a part of it, then test it separately. Two is you always need an evaluation data set, even before you need the metrics. And frankly, there are no metrics here because we're not talking about things like accuracy. We are rather talking about custom criteria which are specific to a use case. I think LLM judges is a great approach. They're not perfect, so use them wisely and always test their quality themselves, but it's actually very, very powerful. So there is no way we can skip on it. But if you do it, always either write the prompts or read the prompts that you use. And evaluations, they will stay with you throughout the whole process. So in this case, it's better to prepare for them from the very beginning than try adding them to the project after you started working on it. Okay, so that was a lot.
Yeah, amazing. Thanks, Elena. Yeah, I took a lot of notes, like entire page, like even more. So I have a few questions. We also have like 4 questions from the audience. I want to I'll ask my questions first. Hopefully they will be quick and then we'll go there. So like I've seen examples of prompts for LLM judges. And yeah, for me, it was also counterintuitive. Like if we use this LLM to generate the answer, it's kind of cheating to ask the same LLM to now grade it. Because like if I do this, then I'm kind of biased. But I guess LLMs don't have that. But anyways, like I was wondering, you showed a screenshot where you said that you included the reasons, right? So you don't just ask an LLM to say if it's relevant, non-relevant, partly relevant, but you also ask it to explain. So why do we usually do that?
Because LLMs, they're actually doing the reasoning, right? They're predicting the next token, which will be much more realistically follow from an explanation which leads to this token, right? So if you want LLM to say it's toxic or not toxic, having the previous reasoning, which will say, hey, actually this response has curse words in it, will be much probable to result in the word toxic than non-toxic. So it's actually for reliability and as well for you to evaluate the responses.
Uh-huh. Okay, so it's for debugging, but also this way, actually, the responses will be better, right?
Yeah. There are even more sophisticated methods like real chain of thought, but this is like a mini chain of thought inside the prompt, so to say.
And chain of thought is when you have multiple calls to an LLM,
Yeah.
right? So
Multiple prompts, yeah.
multiple prompts. Okay, and and to me, like this looks more like art than science when it comes to coming up with these prompts. Like, how do we actually do this? Like, how do we build a prompt for the judges? Like, what I did once is I just asked ChatGPT to write me a prompt, but then again, I asked an LLM to write a prompt for evaluating the output of an LLM with an LLM.
Well, it should end with human labeling, just like I showed. So I think like this is the best thing that you can do. Try to label it yourself. When you start labeling, you actually understand the criteria that you make in the decision on. Then you write it down, and then you can use an LLM to generate maybe a more complete prompt. But I found that like this kind of like, for example, relevance or not, right? If you have not looked at your own responses, you don't know what you mean by relevance. But if you look at specific responses, you might actually decide, well, if it even has like a partial response, please say it is relevant. Because in use case, you might have like multiple chunks. So even if it's one of them is containing something, you would basically give this instruction. But if you just ask like relevant or not, it will most likely assume that it should contain the complete answer. At least that's how it happened to me. So I think like imagine if it's a junior intern that is not yet very experienced, that you have to be super literal, right? And just write a prompt like this based on how you expect it to be labeled. But yeah, it's more art than science.
Okay. And then like how do we evaluate the prompts in this case?
Human labeling. So I said,
Okay. So like we always need a human at the end, right?
yeah, I mean, you either start like with your own labels, or you first just write a prompt, you generate these labels, then you review them and correct some of them, and then here you are, you have the data set, right? So now you can iterate on prompt a little bit. You don't have to go like completely overboard, but I think like just like these 20 examples, it's great if they're not like super easy, right? Just make them nuanced a little bit, right? So type of things that you actually want to distinguish between.
Yeah, but like another problem I might have is, yes, I can do this human, I can label the data myself, pick 20 examples, try to explain myself why I think it's relevant, non-relevant. But there are probably some best practices for building this sort of prompts. Do you know if there are any, like, maybe not catalogs, but some sort of like place where I can look at existing prompts to get some inspiration?
I actually went through like a lot of papers to see like the prompts people use, and I found that I think people are very dismissive of prompts. So they basically just like they never test different prompts. They just go with something that came into their mind, and then they decide if judge is good or not on the single prompt that they use for evaluation. So I think actually there are not yet enough best practices on this. And if you look at some libraries that like wrap metrics using LLM-as-a-judge approach, sometimes you cannot even find the prompt they use. You have to go like deeply in the code to try to find it. So
Okay.
I think it's not good enough yet, but yes, you can look at the papers, you can use at libraries, like for example, in our library, and evidently we also have like some prompts that we included. But this is also very LLM specific, right? So the way you prompt Claude is different from ChatGPT in a way.
Yeah, right. Okay. And yeah, maybe last question from me. Like you talked about ground truth data set. So in this ground truth data set, what we have is a question to our system and the answer that, let's say, if I do this. So I have a system for, I don't know, health instructor, health advisor, right? So I say, for example, how often do I need to take these pills? And because I have the pills, I can just look the answer and put the answer there, right? And do this for like 10, 20 questions, right? So this will be my ground truth. A question and the correct answer, right?
Yes, or sometimes it doesn't have to have the answer. Like, for
Mhm.
example, these are the type of questions that you want LLM to say no to. Like, hey, should I go to ER, right? So you don't want to answer this question. You just say like, hey, call the ER, right? And then you can have like hundreds of different questions to which you think you should respond this way. Or like maybe
I see.
questions, or maybe questions about competitors in different ways.
Yeah,
Like, how
yeah. Like
is
I
better?
remember now your slide where
Yeah.
you said like common use cases. Then second one, I don't remember what
It
was
was
that.
it was adversarial use cases,
Yeah,
and
right.
it was edge cases, right? Edge cases
Which
could be
is
like maybe some information about particular medicine or particular conditions, right? That are rare. Like, can you answer this to me? Like, if I'm 12 years old, like I think, hey, I'm 12 years old. How can I use your fitness assistant? That's an edge case, right? So you probably say like, go talk to your parent.
yeah. Or don't mention your age again, right?
Well, I'm not recommending that.
Okay, so we have a few questions from the people who joined in. And yeah, maybe this is something we can do a bit of brainstorming together. So if I'm building a rack based on PDF documents, how can I evaluate it?
I actually had a slide that I brushed over, so if you stop sharing, I can share that one very briefly on what is the possible ways to evaluate RAG. So I would actually agree with you, like let's brainstorm it, because I think you can approach this from the first principles. And my experience so far was like there are three parts of what matters in RAG. One is the quality of retrieval. Another one is just the quality of your overall database. And three is the quality of generation. And you can evaluate them separately. And the first part is just the retrieval quality. And I think this one is pretty well solved with classic search. The only thing that is lacking is the labels of relevance, right? So you either have to go manually, like find all the relevant documents to a particular query, and then see if the LLM can find them, or you can use the LLM-as-a-judge to label relevance, right? In this case, you cannot have like recall evaluated, but you can evaluate like precision and ranking quality or hit rate and so on. So in this case, I think this is what you first need to work on when you try to find like correct documents. But this requires you to come up with these questions and label relevance. And then there are other things to
And
evaluate.
questions, ideally, I come myself as a developer, as an author of the tool, of the product. I do it, right? So I can also ask an LLM to generate this, or perhaps maybe I use users, right? Because you mentioned if we just use an LLM to generate questions for our answers, then it will be biased.
It's not, you can go with it, right? But you can probably augment it with something like with chatbots, with customer support chatbot, with like the most popular use case ever. You have the history of previous questions, right? So then just test. You even have history of previous answers, right, that you can compare against.
Mhm.
Or just like ask yourself. I found that like without the generated questions, it's a good start. But yes, they're limited by the fact that you ask about something that you expect to have the answer for, right? In a question that kind of like matches the language used in the answer.
Mhm.
But yeah.
And then, like, there could be cases when, for example, it's a new chatbot. We did not have a chatbot without LLMs. So, I don't know, we just want to integrate a new chatbot. And then we don't have a history. And in this case, we need to think what kind of questions user might ask before we actually roll it out, right?
Yes, you can think or you can actually expose it to users, but just like don't
Yeah,
make the
okay.
chatbot, right? See what
Uh-huh.
the questions have been typed into.
Uh-huh.
And then it's
Okay.
respond to them manually, right?
Right, like intercom sort of thing.
Yeah. So I mean, there are ways how you can creatively curate this data sets. It doesn't have to be like super complicated. I'm sure like from the top of your mind, knowing your product, having spoken to your users before, you can come up with 100 of questions.
Right. And then I remember the slide you just showed. So the first one was evaluating retrieval. The last slide was evaluating like generation.
Yeah.
And in the middle, not slide, but like you have three columns. And
Yeah.
in the middle column, it was evaluating the knowledge base itself.
Yeah.
Like, what does it mean? Like, do we, again, we use the questions that users ask and we just think, okay, like, can we even answer this question using our knowledge base?
Mm-hmm. Yeah, so the approach how you test it is the same. It's just like the metrics, right, that you look at are different. So specifically for the knowledge quality, I found like two types of judges that are relevant. One is basically asking, hey, can we answer the question asked? Like here's the user question, right? With the context that we retrieved.
Mm.
And you just want to know that there are some questions that you cannot answer, right? And then there is a way how LLM handles it. Maybe it says, I don't know, maybe it hallucinates, right? This is a separate part. But you yourself want to detect it because it's a separate problem. It may not be that your retrieval is bad. It may be that you just don't have the answer, right? And one thing in particular that I noticed is also called like intercontext contradiction, especially like if you have, for example, a huge knowledge base that you're parsing chunks from, sometimes it actually contradicts itself. So you have like two pieces that are relevant, but one says, yes, we have this policy, another one, we discontinued this policy, right? And this is the type of thing that you should detect separately from, hey, is the LLM response good or not? You cannot even identify if it's contradictory or not because it contradicts one part and agrees with another, right?
Mm-hmm. Yeah. And because the question is for PDF documents, I guess you also need to check the entire system, like how it correctly extracts information from PDF, right? Because it's not text. You also need to do some preprocessing.
Again, it's text, right?
Mm-hmm. Do you recommend a particular framework or tool for logging the replies and the metrics? I wonder what your
I wonder
recommendation
which
would
tool
be.
is that. No, we actually, like, evidently released a separate tool, which is now called Tracely, that is for that, and it's based on OpenTelemetry. But honestly, you can do OpenTelemetry is an open source standard for logging, right? It's just like adding a few pieces on top of it so you can easily wrap the text part. I think there are quite a lot of tools right now. Just use whatever you're comfortable with. Honestly, I was surprised that people are now building so many frameworks because there are tools that exist from 5 years ago that you can use, but I guess we like
Mhm.
the new thing.
Mhm. Do you know if with MLflow we can log it, or
I think you can,
at least
but
like for some local
I
offline
think for
experiments?
experiments, yes, so it will
Yeah.
record, yeah, not for the production,
Mhm.
like great
Yeah,
institute.
right. Okay. And then what we also showed in the course is like the simplest thing. You have Postgres and you start inserting like things
Yeah,
to
exactly.
Postgres.
I mean, it gets complicated when it's multiple
Yeah.
chain function calls, but if it's input output, I mean, you can write it yourself.
And maybe let's take the last one. How can I choose an LLM to build a judge?
Try different ones. But I would say I would default to using the more powerful one. So if you can afford using external LLM, don't spin up a local LLM to run judges. You just get better quality with GPT. If you have small volume, go with a more complex model. And then when it comes at scale, you can evaluate simpler model against the more complex one. But just default to more powerful model and then test.
So, for example, if we use OpenAI, so they have GPT-4o and GPT-4o Mini. And Mini is like 20, if not more, times cheaper. So I guess a good approach would be just run both and see how they compare. And if they contradict, then evaluate the cases where they contradict. But if they don't, if they always come with the same kind of judgment at the end, then you can just go with a cheaper one, right?
Yeah. But if it's like small volumes, and I see that most people, they don't deal like, with millions of rows.
Yeah, right.
It's
I
probably
mean,
not
like GPT-4o becomes expensive quite quickly, like it just adds up. I don't know.
we
So,
actually default to mini. I default to
mhm.
mini. I think it's
Yeah,
good.
and Mini is just like for the course I implemented the project, and it costed like 20 cents. And there was one evaluation I ran with GPT-4o, which costed like $1, right? I mean, it's not much, right? But like, I mean, if you compare the scale, like doing the entire project is just, I mean, a few cents versus one evaluation, and it's like a lot more.
Actually, I've heard from several teams that they spend more on evaluation than on calling, especially
Yeah.
if one call to generate the response, and then they use like some library that makes many calls to generate the evaluation.
Okay, Elena, thanks a lot for your presentation, for sharing your experience with us, your knowledge, for answering our questions, and thanks everyone for joining us today. I'm sure you have learned a lot of new, interesting things, and I know that there are students from our LLM Zoom camp who are watching it right now or will watching the recording. I'm sure it will be very useful for the projects. So thanks, Elena, for joining us.
Thank you. Bye-bye.
And yeah, looking forward to seeing you again, maybe not in 3 years, but
Not in 3
earlier.
years, a bit sooner.
Yeah. Okay. Have a good
Bye-bye.
day. Bye, everyone.